Alright, so this is just a quick video about what is a vector and sort of an introduction to vectors. So a vector is something that has direction and magnitude. And well, what is direction and what is magnitude, you might be asking? Well, direction is pretty obvious. It's what it has to point in some sort of direction. It can't just be some number. And in that case, some number is really the magnitude. So magnitude would be the size of it. So let's just say we had our vector like this, and let's just call it v. Its direction would be the direction it's pointing in, and the magnitude would just be the length, like right there. Which is nice, right? So what are some examples of a vector? Some example of vectors include velocity. This is the most common one. Displacement is another very common one. Not to be mistaken with distance. Not the same thing. Distance does not have a direction, but displacement does. Or I should say that distance is the total distance traveled, and displacement is simply the starting position and the difference with the ending position. So you can take whatever route, and this is the displacement, but this is the distance. So that's just the main difference to make, and don't confuse those. Acceleration is another one, and these all have direction. So what are some scalars then? Scalars are something with just a number attached to it. So that would be like mass, so like how massive something is. And then you also have speed, which is not to be mistaken with velocity, because speed is the magnitude of velocity. But speed doesn't have a direction, so it's not a vector. And then you would also have something like energy in physics, but you don't really need to know this one in math. Energy is measured in joules, and it does not have a direction, it's just a value. So from here, well, what can you do with vectors? Well, you can add them. So vectors have something called component form, which is how you would display something. So how would you write it if you wanted to add it, right? So like if I wanted to write v plus let's just say u, I wanted these two. How could I really like figure out how to add those? Well, let's just say that we had our vector v right here, and it's 2, 3 in the xy plane. So if we know it's 2 and it's 3, then we can display this as 2, 3 like this, and make sure to use these pointy brackets. And what if we had u like this, 1, 4, and this is u. So this can be displayed like this. And in order to add these, you would just add the components. So the first number is called the x component, and the second number is called the y component. So you would add the x's and add the y's and keep it in the same thing. So let's just say we have our resultant vector, which we will call r. The x's combined is going to be 3. The y's combined is going to be 7. So this is how we would display the resultant vector in component form. So you display the x component and you display the y component, and that just tells you that. So what if you want to find the magnitude? So like, now it's nice to know that this is 1 tall and 4 wide, right? But how long is this really? So in this case, what you would do is you use Pythagorean theorem, which is kind of obvious. You just take the a squared, b squared, and that should be this squared, right? This length squared. I should probably mention that magnitude is displayed as an absolute value. So if you do this, this is called the magnitude, magnitude of the vector u. And this is the length of u. And we can just use the Pythagorean theorem, and that gives us 1 squared plus 4 squared, and then square root of 17 is the magnitude of u. And this has the units, so let's just say u is a velocity vector. Then you would put meters per second to get the units. So magnitude will always have the units involved. So the second thing you would want to know about a vector is, well, how do I know what direction it's in? Because it's nice to know that I can see where it's going, but what really is the direction here? So usually we will describe direction as a form of an angle. And from here, we can find that, let's just say, for example, we have our vector u, and I'm just going to change this a bit. And this will be 3, and this will be 4, just to make it easy on us. So that's 5. And we'll call this inside 1 theta. So quickly revisiting the component form, if the first part is just y, if the first part is just x, and the second one is y, we can actually use our trig to find these values. So if we go like this, so for u, what if we didn't know that this was 3 and we just called it x? So let me erase these. In correction, this should be y and this should be x. So if we want to find y, which would be this value in here, how do we do it? Well, we know that sine theta is equal to y over 5, as by definition. So 5 sine theta equals y. And obviously you can just use cosine for x, so 5 cosine theta is equal to length x. So this is how you can find any component if you know the angle. Now, like I said, we want to work vice versa, right? Imagine we knew that y is equal to 3 and x is equal to 4. How do we find theta? So we just use our simple trig inverse function to use arctan. So if we know that tangent of theta is equal to y over x, right? As given by the sine theta over cosine theta, or the opposite over adjacent, we can get that this is equal to 3 over 4. And if we want to find out theta, we just have to use our inverse trig function, which happens to work really well here. So this will give us arctan of 3 over 4 equals theta. And this would be the exact solution, and obviously you can also plug it into a scientific calculator to get an approximate solution. So I'm not going to plug that in right now, but that will give this angle theta. And that's really how you would use it. And if you want to get really technical, so like if you were asked how do you describe or define the vector u, you would say that if you knew it was like this, these some certain values, right, then you know that the direction it is in must be arctan of y, this y, over x, this x. So like this. And that's how you just find the general solution to any direction of a vector. Other than that, there's not much to know. One quick note is that in some fields, you will use something called unit vectors. And this goes back to the idea of components and something called scalar multiplication. So scalar multiplication is the ability to multiply a vector by a scalar, or just a number. So let's think about it like this. Let's just say this is my vector v, and I multiplied it by 2. So what would I get if I drew out 2v? Well, naturally, it's something that is 2 times the length of the first one. But notice how the direction does not change. So I should probably note that. Direction doesn't change. And since direction doesn't change, it's pretty helpful for something called unit vectors. So our first unit vector is I. It's the vector I. And our second one is the vector j. And it's kind of annoying that they are just mirror images of each other, but we deal with that. The unit vector I is defined as 1 unit in the x direction. So this would be like this. No problem, right? So j, obviously, as you can expect, is going to be exactly 1 unit in the y direction. And these are super helpful because these are sort of building blocks. Now, let's think about it. If these are 2, and I have them labeled like this, if we had a function that was equal to the sum of these, so notice, remember, our component form addition is done here, right? So if we have the sum of I and j, that gives us this vector, right? Now, what if we scalar multiplied j by 2? So 2j is equal to this, right? Because the 2 gets multiplied like this. It gets distributed. And the 0 will always remain 0, which is nice. So this 2j goes to here, and then you can build this vector. Or you can scalar multiply by a negative number. So I forgot to mention, negative v would look like this. It is in the same angle of direction, but it is flipped exactly 180 degrees. So back to this topic. So if we want to go in like this direction, how would I build this vector? Well, that looks like negative 1.5 j's and negative 2 i's. So we would do negative 2 I like this plus negative 1.5 like that. And that's how you build this vector. Let's just call that r. So that's just basically the premise of unit vectors. They're building blocks and they describe all the other vectors. And to be clear, this is only working with scalar multiplication. This is not talk about the dot product, which is something I'll talk about later. But the dot product is something else, but it is also a form of vector multiplication. This is just multiplying by a number to manipulate the length of a vector. And that's really all you need to know to dip your toes into vectors. There are some more complicated problems that can be done, but I will talk about that a later day.